Sometimes the only difference between an ugly, inaccurate 3D print and an immaculate one comes down to slicer settings. From improved part accuracy to flawless surface finishes and even fixing unprintable geometry, there are so many things that your slicer can do to help you get better, more reliable 3D prints. So in this video, we're going to explore over 30 powerful and lesser-known slicer settings to help you go from this to this. And let me just tell you, I nearly kicked myself when I discovered number 29. So go ahead, flip that toggle switch to advanced, and let's get after it. Slicer and printer configuration. Now, before we get into the actual slicing, let's go ahead and optimize the configuration of both your printer and your slicer themselves. As you'll notice, I'm going to be demonstrating most of these features in my slicer of choice, Orca Slicer, but because most of the major slicers already share a large part of their code base, you should be able to find many of these features in all the common slicers. But if you're still an Orca Slicer holdout, I'm pretty sure that this video will be the one to pull you over the edge. Okay, let's go ahead and get started with auxiliary fan, air filter, and chamber temperature controls. You see, back in the day, if you had an auxiliary fan, a chamber heater, or an air filter on your 3D printer, you had to rely on adding custom G-code to your various profiles to actually turn those things on and off during a print. But no more. Orca Slicer now offers a graphical user interface for configuring these and will then add the G-code behind the scenes, provided you've already set up the appropriate M106 G-code in your printer's configuration. Now, to enable the auxiliary fan control, just go to your printer's general settings and scroll all the way down to the bottom. Once you have it all set up, all the tuning will happen directly in your filament profile, which brings us to shared filament library. So not so long ago, if you'd spent a lot of time customizing the standard filament profiles or adding your own, say by tweaking those chamber and auxiliary fan settings that we just talked about, you would then have to copy and paste them for each one of your printers, assuming you had multiples, because filament profiles were tied to printers. Fortunately, Orca Slicer now allows you to remove those dependencies or customize them if, for example, you don't want to show ABS profiles on your open printers. Now, Teaching Tech has a wonderful tutorial all about this, and I'll link it below. But I just wanted to bring to your attention that you can now share profiles across printers. Also, for those of you who don't have the patience to perfect your own profiles, note that I do share my own filament and printer profiles with my Patreon supporters, and I do take requests. So consider supporting us on Patreon if that's something you're interested in. Now that your slicer is all set up for your printer and your filament, let's follow it up with some convenience and quality of life features that save time and reduce friction. For example, the lock plate function. Have you ever spent like 10 minutes or more arranging every part of a project onto separate build plates by color or material, or selecting only the parts you currently want to reprint on one plate, only to habitually type A or hit auto arrange and lose everything? Super frustrating. Well, it turns out that you can actually lock individual plates using this little icon that's apparently been there all along. And once you do, auto arrange won't mess with it. Pretty handy. Don't support bridges. Here's another annoying situation that it turns out can be fixed with a simple check of a checkbox. While automatic supports are generally quite good these days, and I use them most of the time, they often do try to support bridges. Now, up until now, I've solved this by either switching to manual supports and then painting only the areas that I want, or adding support blockers on the bridges, again, manually. But now, there's no need to do this. You simply go and check the Don't Support Bridges checkbox and enjoy automatic supports as usual. Nice. Disable step mesh parameter setting dialog. Up next, let's talk about step files. As I recently mentioned during a podcast interview with open source designer Glenn Woodhouse, I've recently been pushing for the 3D printing community and the various file sharing sites to move away from mesh STL files as the default and towards step files, which are not only already supported by almost all the major slicers, but are also much easier to import into CAD software and then remix. But another small annoyance when working with step files in your slicer is this pop-up dialog, which asks you what resolution you wish to import. Fortunately, while poring through the Orca Slicer wiki in preparation for this video, I discovered that you can actually disable that dialog box by just going to the Orca Slicer settings and disabling Show the Step Mesh Parameter Setting dialog. 3MF handling. While you're in there, another annoying pop-up dialog box that you may or may not need is the one that shows when you open a 3MF file. If you only ever want to open 3MFs as a project, or you only ever want to import their geometry, just note that you can actually set one or the other, or ask, or better yet, you can now set it to ask when relevant to only show that dialog box when there is actually something besides geometry in the file. This can be really useful if, say, you don't have a multicolor printer and you never want to import other people's painted models into your slicer. Just be aware that you will also lose the print settings if they're in there if you choose to always open only geometry. Skip Home tab and splash screen. Okay, here's one more annoyance that adds unnecessary steps when you're getting into your slicer. Did you know that you can actually skip the splash screen and launch straight into the Prepare tab, which I assume most of us exclusively use? This is great if you, like me, never use that Home tab and you want to save a click and just get right into slicing. Speaking of saving a few clicks, if you, like me, have multiple slicers on your computer and are always opening files in different ones depending on what printer you're using, make sure you check out this little slicer picker application that I vibe coded. I really hate that term, but that's what I did. Basically, you set it as the default app for step, 3MF, and STL files, and then when you open or download one of those files, the app will ask you which slicer you want to open it in, saving you a step. I actually also have a setup on my Mac, which whenever it sees a file of those three formats in my downloads folder, it will just automatically open that slicer picker, which is pretty cool. I currently only have a Mac version of this, but if any of you wants to remix it for PC, feel free. I'm sure ChatGPT could do it in just a few seconds, but I have no way to test it out on my own because I'll f with Microsoft. Dimensional accuracy and printability. Now that your user experience is tightened up, let's do the same for your prints themselves with some settings to improve print accuracy, starting with holes. XY hole compensation. As you may already know, because of the way our 3D printers work, when it comes to holes, accuracy can be a problem, among other problems that we'll get into in a second. For holes in that XY plane, we actually have a number of tools at our disposal for fixing that problem. The first is called XY hole compensation, which allows you to simply compensate positively or negatively. Now, this can be great for correcting your printer's inaccuracies, but don't limit your usage to that. I've actually used this tool to entirely repurpose models, change hardware sizes, or just save me from needing to update my CAD drawings when I change a design. Polyholes. With that said, if you really want to get things right and accuracy really matters, you might want to check out the lesser-known feature, Polyholes. This converts your holes from perfect circles that your printer tries to recreate to actual polygons, forcing the printer to create very specific straight lines of G-code. Now, I'll be real with you guys, I haven't actually had a chance to use this one yet in a project, but if you model for it and dial it in, it supposedly delivers crazy accurate results. Personally, I could see myself more likely to use it to intentionally make holes that, say, only minimally contact my hardware, as just one example. Bridge CounterBore holes. But as I alluded to before, accuracy is only one part of the challenge when it comes to 3D printing holes. Another is bridging, particularly in the case of holes that face the build plate. And if you look at some of the best, most 3D printing optimized parts, like those made by the Voron design team, you'll notice that they account for this with a very clever trick, which creates bridge counterbored holes. In other words, there is a small sacrificial layer or a series of bridges in the case of counterbored holes to allow the printer to properly print those holes. Believe it or not, you can actually do this in Onshape automatically using a feature script, but what about for models that you just downloaded from the web? Well, fear not, because there's actually a feature built into your slicer to handle this, and it's called bridge CounterBore holes. By the way, I haven't been telling you where to find each of these features in the different tabs of the different slicers because I personally recommend that you just use the search function in your slicer of choice rather than trying to memorize which tab has every one of these features. Now, there are two options here, sacrificial layer or partial bridge, depending on what type of hole you're working with. And yes, they are applied automatically to any applicable holes. Pretty awesome. Precise wall. So that should have your holes nice and tight, dimensionally speaking. But what about the rest of your print? For that, we have a bunch of different settings, starting with precise wall. Basically, what this does is adjust the spacing between the actual perimeter extrusions of your print, sacrificing strength for accuracy by reducing the amount of overlap between the perimeters. If you're curious, Minimal 3DP did a great video actually testing this out, which I'll link down below. So if XY accuracy is a priority for your next project, definitely check this feature out. Precise Z height. But what about Z accuracy? I'd never thought about it before, but it turns out that if you have a model that needs to be, say, exactly 20.05 millimeters, unless you choose increments of 0.05 millimeter layer heights, the slicer will round things down, giving you 20 millimeters. That's where precise Z height comes in. It forces the slicer to calculate that last layer, even if it's below the layer height, giving you, at least in theory, a more precise height. Now, I'll be real with you guys. Again, I can't see myself ever needing something to be that accurate, but it's good to know that the option is there should you need it. Now, if you're watching this video, chances are you're interested in taking your 3D printing and design skills to the next level. I mean, who isn't? But of course, slicing is only one part of getting those perfect prints and projects. You also need to design them. And that's why I'm a huge fan of this video's sponsor, Onshape. Onshape is a professional-grade CAD and PDM suite that works a lot like Google Docs. You can collaborate on your designs with other people in real time, whether on your phone or your computer, and you can keep track of design features with history, branches, versioning, and even unlimited restore capabilities. I also especially love the feature script function that I mentioned before, which allows you to perform complex design functions without all the manual labor. If you're an engineer and you need to access their pro features like CAM, you can get up to 6 months free of the professional plan using my link. I've been using Onshape personally by choice for years, and it really is the only CAD software that I find intuitive. So to check it out and get started for free today, visit the link in the description or scan the QR code appearing on screen now. Thanks again to Onshape, not just for sponsoring this video, but for making the only CAD software I can get along with. All right, let's get back to the video. Print quality. With those few settings, your parts should print and fit better than ever. Now, let's make them look better as well, starting with a pretty well-known one, scarf joints. Print quality has honestly gotten really good over the last few years, with ever more tricks to hide things like layer lines. We've gotten to the point where a lot of the time, when you look at a 3D printed part, the seams are one of the last remaining artifacts that show that a part is even 3D printed. Now, Angus over at Maker's Muse recently did a very informative video all about choosing the right seam type and how the different ones work. So I'm just gonna link that one below rather than rehashing. But I do just wanna say that if you aren't currently using scarf joints to make your seams even less visible, you really should, and I hope that more printer manufacturers will start enabling them by default in their default printer profiles. Single perimeter on top and bottom surfaces. Another dead giveaway that an object is 3D printed is the presence of individual perimeters, particularly on the top and bottom surface, which you can often see even if a textured build plate was used. Now, recently, a number of my favorite creators have done videos on ironing and how to dial that in. So I won't go into that again in this video. We'll just link in the description again if you're interested. But I do want to point out one quick setting that I don't see nearly enough people talking about, and that's the setting to enable a single perimeter on the top or bottom layer. No, it won't create the same smooth finish as perfectly dialed ironing settings, but it also doesn't add hours to your print times either. And the results can often be significantly better than the default settings, especially for functional parts where you can't afford the dimensional sacrifice that comes with ironing. So try it out. Small area flow compensation. But what about the little gaps on those top and bottom layers? You know the ones I'm talking about. The areas where the extrusion line is too thick to fill in those tight, sharp angles. Well, it turns out there's now actually a setting to fix that. It's called small area flow compensation, and it tells the slicer to boost flow in those areas to help fill them in, per object skirts and draft shields. But I suppose all is for naught if your print is stringy, warped, or otherwise ugh. And unfortunately, with tool changers and multi-nozzle printers becoming ever more popular, I think we're going to start seeing stringing and oozing becoming a more significant issue once again, since these printers need to keep the nozzle warm, then transition back and forth from the purge block to the dock to the object. Not to mention, the longer print times can easily lead to warping. Fortunately, it turns out that our slicers are already equipped to prevent that. Did you know that you can actually specify skirts and draft shields per object in Orca Slicer? Meaning, if you want to prevent stringing between the purge block and the first object on the build plate, you can specify a draft shield which will catch any stringing before it attaches to your model. Now, this has the added benefit of reducing the risk of warping for that model. Plus, it acts as cheap insurance in case your purge block detaches altogether, which I've definitely had happen a whole lot with multi-material printing, especially because the construction crew across the street seems to keep knocking out the power every time I try to do it. Anyways, super cool, am I right? Mouse ears. While we're on the topic of warping, let's talk about mouse ears.
Booker, first ever. Oh.
No. Not those kinds of mouse ears. Mouse ears are a way to give your print some added bed adhesion where it needs it most, without the hassle of brims all the way around the part, which will then need to be deburred away and which sacrifice a little bit of that edge accuracy. By using mouse ears, we can save material and print time as well. In Orca Slicer, we have the option for either manual or automatic mouse ears right in the brim drop-down menu. So next time you're considering using a brim, maybe try to give mouse ears a try instead. Ironing support interfaces. As I mentioned earlier, ironing's been getting a much-needed revisit recently, but one new feature and aspect of ironing that I haven't seen anyone talking about is ironing support interfaces. As with most of these features, the name pretty much says it all, but this one should result in cleaner surfaces and less scarring. Hopefully, I'll get a chance to test this one out when my kids aren't home from summer vacation and bouncing off the walls. Strength. With our parts fitting and looking their absolute best, let's now switch it up again and talk about part strength. You might think that strength only involves selecting perimeters and infill, but there are also a lot of fine-grained features that can really improve the strength of certain parts of our 3D prints. Take, for example, thick bridges. If you find yourself needing a stronger bridge, even at the expense of aesthetics, say because a bridge is used in an area which is going to attach to the hardware, you need to make sure to check out the thick bridges feature. It basically extrudes a thicker, beefier line on the internal or external bridges, which can then improve bridging distances, but which may look slightly worse. Bridge infill direction. Have you ever had a model that, for whatever reason, the slicer didn't want to properly bridge? I certainly have. Or perhaps you just wanted the infill to go in a specific angle, say for aesthetic reasons or strength purposes. Well, now you can specify just that with bridge infill direction. Not much more to say about that. Extra bridge layers. While we're talking about bridging, let's also mention extra bridge layers. Now, this beta feature allows you to print an extra slow layer above your bridges, which will then better support the coming solid infill. This is particularly useful on large bridges and fast printers where bridging speeds and cooling performance can vary. So if you need a stronger, better looking and bigger bridge, try this one out. Special purpose. So we've covered printability, accuracy, looks. All that's left is to cover some special purpose functions that allow your slicer to do unique things that would otherwise require you to fire up CAD, starting with close holes. Earlier, we spent a lot of time talking about how to get your holes as accurate as possible. Still, sometimes you don't want holes at all. For example, if you download a model that has holes for magnets, but you're planning to glue the part together. In that case, I cannot tell you how many times the close holes feature has come in handy for me. It's pretty self-explanatory. I mean, it just causes the slicer to ignore holes in X and Y, but it's surprisingly useful in a lot of different scenarios. Infill Multiline. Now let's talk about Infill Multiline. In one of my earliest videos, I talked about a trick where you can remove top and bottom layers of a print to let the slicer create a mesh for you. This is useful for all kinds of things, from phone cases to sieves or fan grills. But what if you need the infill pattern itself to be a little bit stronger and beefier? Now, in the past, you could only control the number of lines in the Z-axis or the infill percentage, but that would modify the size of the holes. So with this brand new feature, you can also control the thickness of the actual infill pattern itself. Now, this feature is so new that I haven't even thought of any potential practical applications for it, but I'm pretty sure that you guys will in the comments below. Beam interlocking. Now, here's one for those of you dabbing in multi-material printing or eagerly awaiting your pre-order of that Snapmaker U1 that I recently featured. As you may or may not know,
I'm gonna tell you something about me, Joe Rogan, that you might not know.
some plastics don't bond well together, which can be a real pain in the butt if you spend a full day 3D printing something only to have the materials separate. Fortunately, someone has actually already thought of this and created the beam interlocking feature. As the name suggests, this feature basically stitches the materials together, not just in X and Y, but also with interlocking Z layers, giving you an incredibly strong physical connection that will hold any two materials together, even PLA and PETG, though I'm really not sure why you would mix those specific two materials, but hey, at least you know you can. I'd love to know in the comments below, did I miss any power user slicer features that you find super handy? And don't forget, if you'd like to gain access to my Orca Slicer profiles for new printers and filaments, you can do so by joining our Patreon using the link in the description. Oh, and we do still have some of these shirts available, but act now because supplies are limited. That's all for this week, but I'll see all of you on the next layer.